All right, so in the last video, we got to this point where we saw that the average power is just going to be the IRMS times VRMS, which we can call that the apparent power, which we haven't talked about yet, but that's just a name for it. The apparent power multiplied by the power factor, which is the cosine of the phase shift, the phase difference between the voltage signal and the current. Okay. And so that's the general formula for any load. Of course, we talked about how in the case where the load is resistive, the phase shift between the voltage and the current is 0. This term goes to 1, and we're just left with the original formula that we saw, which was IRMS times VRMS for the average power. Okay. However, the general case includes this cosine term called the power factor, which can scale the average down depending on the phase shift. Note that we already did this, but we didn't see it in terms of a formula, but I just want to show you that you can basically convert to this other form of this equation if the signals you're working with are sinusoidal. Okay, so we're typically working with sine waves. That is the general standard for power. Power is transmitted sinusoidally. It's generated sinusoidally and transmitted sinusoidally. You know, the power that you get from your outlet in your house. If you have your little outlet here, there's a sinusoid coming out of that outlet. Probably should have made this clear already, but basically there's 3 terminals on any outlet. You have the hot. Well, I guess the hot is the smaller of the 2. I need to draw one a little bit bigger than the other. You have the smaller, the bigger, and then you have ground. This one is neutral. This is the hot, and then this is the ground. The ground is a safety feature. Really, the hot and the neutral are the 2 that we care about. So if we have a circuit that has some kind of a source and we have a load, this line here is the return path to the source. This is the hot line, and this would be the neutral line. Okay? And then ground is off somewhere else as a safety feature. We're not going to get into all that right now, but in your house, what you have is you have 120 volt RMS sine wave at 60 hertz, which is equivalent to 169.7, I believe it is, times the sine of 2 pi times 60 times t volts. That is the standard power or voltage signal that you have at the outlet in your house. Okay, so when we say, oh, it's only for sinusoidal signals, you might be inclined to think, well, why would I care then? Because what if I can't use it for other types of signals? Well, the general case is that we are using sinusoidal signals. Sorry, that's a lot to say. So it's useful to do all these things when we say, oh, okay, in the case of a sinusoidal signal, we can assume, that the RMS voltage is just the peak value divided by √2, or that, and we're going to use that fact right now, actually. So if we remember that VRMS for a sine wave is equal, especially, and this is for a sine wave that's oscillating around 0, right? For a sine wave that's oscillating around 0, it's equal to the peak value divided by the square root of 2, or the max value divided by the square root of 2. And so if we take this formula here and we evaluate, we can say that IRMS is going to be I max, the peak value, over the square root of 2. And VRMS is V max divided by the square root of 2. And that whole thing is multiplied by the cosine of the phase shift. Well, if I take 1 over √2 times 1 over √2, I basically get this formula here, which says that my average power can be rewritten, not in terms of the RMS values, but in terms of the max values of my signals. 1/2 times the max current times the max voltage times the cosine of the phase shift. And that might be a nicer formula to memorize if you don't like RMS values, or if you just prefer to, instead of thinking about RMS, you just want to think about the peak values of your current and your voltage. This is a nice, concise way to rewrite the average power in terms of maximum values rather than in terms of RMS values, okay? Although they're they're literally equivalent. It's just saying this is my RMS, this is my RMS. I'm pulling these 2 √2s out and just making it a 1/2 and then writing it in terms of the max values. Okay, so that's another unique way for particularly for sinusoidal signals that you can write the average power or determine the average power supplied by a source or dissipated by a load. If you know the current and the voltage for that particular element, you can find this average power just like this or like this, whichever you prefer. Okay, so I'm going to go ahead and end this video here. And it looks like in the next video, I'm going to talk a little bit more about apparent power, which we already talked about. This term right here is the apparent power. I'm just going to talk a little bit more about that exclusively in the next video.